Hello, my name is Kalea, and I am going to be doing my presentation on the empirical rule. So the empirical rule says that for data that has a normal distribution, 68% of that data will fall within one standard deviation of the mean. 95% of the data will fall within two standard deviations of the mean, and 99.7% of the data will fall within three standard deviations of the mean. So data is normally distributed in a bell-shaped curve around the mean when graphed. So the values of the data point are along the x-axis, and the number of data points for that value are on the y-axis. This bell-shaped graph will look like this. Okay, so your bell curve should look like this. Be maybe a bit more symmetrical than that. This is supposed to be a symmetrical bell curve, with the mean going straight down the middle. That's the mean. So this line right here, this would be one standard deviation below the mean. This would be two standard deviation below the mean. And this would be three standard deviation below the mean. And the exact same goes for the other side, except it would be above. So this is one standard deviation above the mean, two standard deviation above the mean, and three standard deviation above the mean. So if you take that, and you look at it, then you will see, you will see that 68% of it is going to fall within one standard deviation of the mean. %95 will fall within two standard deviations of the mean. And 99.7% will fall within three standard deviations of the mean. So it's important to remember that the standard deviation describes how spread out the data is. So it should have the same unit as the data has. For example, if the data points are in heights of people, and the heights are described in inches, then the standard deviation will also be in inches. So now I'm going to show you the formula for the standard deviation, and I'm going to draw it up here on this piece of paper, and then once I'm done drawing it, I'll explain it to you. So I tried to bring it a little closer so you can see it, but I don't think that you can, so I'm just going to bring it down over here. So n is the number of data points, the xi's are the value of the data points, and then the x bar is the mean of the data. So that's what the formula is. So now I'm going to give you a real-life example of the empirical rule. So the data is going to be set in pounds of the horses in Plumas County. So if there are 1,000 horses, our N will be equal to 1,000. There will be 1,000 XIs. So the XI for every 1,000 XIs. Each corresponding to the horse's weight. Suppose that we use this formula here to calculate the standard deviation of our set of data. we get that the standard deviation is equal to 200 pounds and that the mean of the data is 1,100 pounds. Then 3 standard deviations of the mean would be 500 pounds to 1,700 pounds. And the empirical rule says that 99.7% of the horses in Plumas County will fall within that range. 2 standard deviations from the mean would be 700 pounds to 1,500 pounds. The empirical rule says that 95% of the horses in Plumas County's weights will fall within that range, and 1 standard deviation from the mean would be 900 pounds to 1,300 pounds. And the empirical rule says that 68% of the horses in Plumas County will have a weight that falls into that range. So this is an example of the empirical rule and how we would use it in a real-life situation. Note that our data size was large enough to assume an approximate normal distribution. Thank you. Hope you learned something.